The goal here is to talk a little bit about blockchains because that keyword is something that you're probably all hearing a lot right now, and people are kind of throwing it around like it's just this sort of fix-all for everything that's wrong in the world, and it isn't, but it is a new way to do a lot of the services and content delivery and things that you're seeing on the internet. And so I think blockchain as a technology is reinventing the internet. So that's kind of what the title of this presentation is about. But inevitably, we have to go back and talk about the sort of killer app that brought blockchains to everyone's focus. And one of those blockchains or one of the apps that runs on a blockchain is called Bitcoin. So we've all been hearing about Bitcoin and the Bitcoin mining activities in the Valley here, and that's essentially how I got started. So I want to try to explain sort of what Bitcoin is, how it works a little bit, get you guys working together and sort of an interactive thing. So the envelope, the manila envelope there on the table, everybody should try to have one, and don't dump it out just yet. But it's sort of, we're going to do kind of a fun little exercise, see if we can do some manual mining here in the room. First, I just want to give a quick little history of what I have been doing and the companies that I brought over here. In about 2012, I got involved with Bitcoin, and I was living over on the Everett side of Washington, and my background is technology in the Seattle area. I worked for Microsoft as a developer for a number of years. Came across Bitcoin in some research I was doing about financial, I used to trade a lot of foreign exchange, trading currencies, and so I came across Bitcoin in that research, and I really was captured by the model, the monetary policy model, and I decided to get really focused on Bitcoin there, and that led to a series of business activities that sort of started there in the basement of my house, sort of like people are doing here, unfortunately, in this area. And I'll talk about why I think that's unfortunate, but quickly realized that that's just not feasible. It's also not safe. So I started looking at, like, what does it take to scale this kind of activity? And I'll describe what this activity really is in a minute. Realized that power cost is a really significant factor if you're going to do this kind of a business. It's just like the data centers where you're going to run a lot of computing devices, and those things use a lot of energy. So if your business is going to be healthy, you need to have low power costs, which that's what attracted me over to the Central Washington area. I was fortunate to connect through the internet. So in other words, I hadn't met this person, and we started a business together. He is a Polish scientist that specializes in chip design. He designed a specialized chip that only thing it can do is process transactions for Bitcoin, but it does it really well, or did it really well for its day. And so with that, we had a competitive advantage, and we manufactured over 1 million chips and deployed them in the Wenatchee Valley area. So basically, I started in East Wenatchee, briefly looked at building something over here on the Chelan County side, but have since just focused everything I've got over in Douglas County and Grant County. So around 2015, we realized that just building a big giant Bitcoin mine that does nothing else except mine Bitcoin for ourselves is actually a bad business model. If you look at what Bitcoin price has done over the past year or so, it should illustrate why that's a bad business model. You end up very sensitized to the price of Bitcoin in the market, and so you end up live and die by Bitcoin price. And so that's one of the negative factors of that business that's going on here in the Valley, is that some of these guys are just focused on Bitcoin mining alone. And what we did was we began diversifying. So we immediately started getting involved with hosting for investors. And that basically flattens our business model, lets us earn a stable return, and then we can have a much smaller segment of processing that's for ourselves. We also started processing for a number of different blockchains, and then we started really pushing towards the alternative applications for this kind of computing, because there are other things you can do with the processors that we mine and process blockchains with. So I'll talk about that. In 2017, I had some investors approach me that wanted to get really big in this business. We agreed to acquire my previous company and create this thing, Giga Watt. It would take over facilities that I'd built to that point, and then we would launch by building a large new set of projects that use a new design that I'd come up with that I think addressed the needs of blockchain from the standpoint of power infrastructure, like think of it as data center 2.0, that we would go after that, and I'll show you some pictures of what we did there. First, let's talk about blockchain. So blockchain is actually, I kind of want you guys to realize that blockchain is actually in concept a pretty simple thing. It's a pretty straightforward idea. I think people want to make it more complicated than it is, and I think its simplicity is one of the things that has sort of allowed it to spread so virally. So a blockchain is just a system that allows a group of connected computers to exchange and maintain collectively copies of a ledger, so sort of like a checkbook, if you will. And so that's all it is. It's a fairly simple concept, but when you've deployed a blockchain and you have this ledger that's sort of the definition of the proof of all of these different transactions, and you have that worldwide, you have a really interesting thing going on. You have a decentralized system. So in other words, one main power, maybe a government or a corporation can't manipulate that truth. So you have this big ledger that anybody can read, and it has the truth of all of the transactions that have taken place, and that actually becomes this really valuable concept. And we, again, with Bitcoin's the best example. It's the killer app for value transfer, but there are a number of other applications. I'll try to kind of drum up a few ideas that are being worked on where you can store this information in a blockchain and distribute it all around the world, and it becomes a new source of truth that can't be manipulated. But imagine news that can't be manipulated, right? It's news that's being reported by individuals. That would be a unique thing right now. We have a lot of news that's completely managed by a centralized power. So let me see if you guys can see the mouse okay. So the idea is that you've got this peer-to-peer system. Anybody use peer-to-peer applications? If you use Spotify, you're using a peer-to-peer network where you're listening to music, but you're also holding some content to share with other connectors that are connected with you. So same kind of thing with Bitcoin. Bitcoin, if you're sending some Bitcoin from yourself to, let's say, Sandra, you're announcing a transaction, and the transaction is propagating from your peer to another peer to a set of other peers. So it just spreads across the world, and it only takes seconds to transfer out over this whole network. So everybody's maintaining their own copy of the ledger and passing that information on to nearby nodes. So it's a pretty simple concept, and we'll try to talk about why that's important. The reason it's called a blockchain is because a block is essentially a group of transactions. That's all it is. So every roughly 10 minutes, the Bitcoin system tries to gather up all the waiting transactions and wait for a miner to process those transactions into a block by verifying them and then writing them to the block. And that the important thing to realize is that each block is related, is referencing the previous block, and data related to that block is written into each new block. So what's critical about that is that if you're looking at a blockchain and you're validating that blockchain is legitimate, if somebody has gone back here to the very earliest block in the blockchain and made a change and is trying to propagate that as the new truth, like in my world, all the Bitcoin belongs to me back here at block 150. By changing this, it won't validate as people are validating the newest block. And it's just a trick of incorporating data from each block into the next block, from the very first Bitcoin block all the way to the current Bitcoin block. If there's been any kind of a change, it's detectable. And that keeps the integrity of the chain intact all the way back to the very beginning. And that simple concept is really powerful. It means that no central bank can decide to manipulate what really happened. You can go back and verify the transactions from today all the way back to the beginning of Bitcoin, for example, with very low computing energy. In other words, the auditability of a blockchain is extremely cheap, extremely easy to do. So imagine, like, say, another application where your identity information is stored in a blockchain, and you control that. So rather than having your identity information stored on literally thousands of websites, or your credit card data entered into, hundreds of different online shopping websites, where basically sooner or later some hacker, I think we can all agree that sooner or later some hacker will get any information that's out there stored in any databases. We used to be just afraid of it happening, and now I think we can agree that it's inevitable that it's going to happen. And so companies that are building around these older technology approaches they're just waiting for this to happen, where all this user data gets taken. So where we're headed, what blockchains are doing is they're taking this concept of this unchangeable historical chain of data, and they're saying, hey, we could store titles to real estate, and then through literally a digital wallet-to-wallet transaction, we could transfer the ownership of a house or a piece of property. We could automatically execute contract documentation as a result of a transaction. We could store identity data that can't be hacked. We could store health insurance or health histories and record data in a blockchain, and it can't be changed and manipulated, and it can't be taken by some hacker and sold off to somebody else to be used against you later. So I think that the perception of what blockchain can bring to the world is this sort of mind expanding event. It started with Bitcoin. Bitcoin was sort of the door that opened. Like any new technology, if there's a killer app that's just a perfect fit, it spreads virally, and the desire to be involved in it is extremely high, and then it opens the door to thinking about this technology in a new way. So a coin like Bitcoin, just to kind of recap this, a coin like Bitcoin has its own blockchain. Another coin would have its own blockchain. So there are many blockchains being developed, and not all of them work exactly like Bitcoin's, but they all are out to establish this unchangeable ledger of information that's placed there by the computing power that's processing those transactions and validating those transactions. So before we do this sort of mining exercise that involves those envelopes, I want to just sort of go through what is Bitcoin real quick. We'll bounce back to this. So the digital unit of value is oftentimes the word that's used to cover that is a token, a digital token, or a crypto token. And the reason it's crypto token is because there's cryptographic technology that's securing all of these transactions in the blockchain and creating these units of value that within the internet is a unique item. It's unique in the world and can't be duplicated or counterfeited. So the transaction processors, the participants in the system that are taking all the transactions that are waiting in the queue and actually writing them into the blockchain to make them real, those are the miners. So the act of mining is really the act of transaction processing for a blockchain. And the reward that we get for doing that service is the mining reward. And it's also how new Bitcoins are created and released into the world. So a lot of times people talk about not really understanding, like, how can this virtual thing have value? And because they're hung up on like understanding why Bitcoin or some virtual thing would have value, it's hard to kind of break through and actually understand how Bitcoin works. So just to give a sense of some of the ways that there is underlying value, first of all, we're making significant investments into this power infrastructure that's used to secure the blockchain and process these transactions. So anything with a serious underlying investment has fundamental value. It represents this fault-tolerant value transfer system. And what I mean by fault-tolerant is the Bitcoin network, since its very first day, has never gone offline. The participants in the system, so like me, the miners, we've gone offline, but it doesn't affect the peer-to-peer network. The peer-to-peer network is like a self-healing network until maybe the last two peers go offline. So in that regard, Bitcoin's network and blockchains in general can persist and not go down as a service. So the service can stay up all the time, which is hugely valuable. And it represents a lot of computing work, and it represents all the power that was required and somebody had to pay for to actually run all that compute. So there are some underlying values. There is underlying value, not to mention the tremendous amount of innovation and information exchange going on around Bitcoin and blockchain in general that give that value. So when it comes to mining Bitcoins, the block rewards are actually the new money supply system, and they actually act as a subsidy for miners to use that money to go invest and build the infrastructure for this new global financial system. Realistically, the subsidy, the block rewards, the new Bitcoin creation actually tails off over time. So eventually it becomes less and less relevant to our actual business model and the revenues that we point to. And the transaction fees that are included in each block start to become the actual business model. Actually, the entire system will switch to a transaction model. I'll show you some data about blocks now today, and you'll see that the block reward, the new creation of Bitcoin, is actually still pretty important to us, and the fees that are being paid are actually pretty tiny. But that should flip over the next 10, 20 years. But the creation, understand that the creation of new Bitcoins will go on until the year 2150 or something, like another 100 years plus. It's just that the amount of new creation each day or each month or each year is going down, and that's on purpose. That's literally the opposite of the way the current like dollar and other country currencies are working these days, where their model is to print more and more and more money, which reduces the buying power of that currency over time. This is why Grandpa's house was $8,000 in the 1950s, and that same house can sell today for $300,000. It's not because houses go up in value, it's because the buying power of the dollar has dropped that much. And that's inflation. That's fundamental, that's the fundamental economics of it. Bitcoin works the exact opposite. If you think about Bitcoin now, what we've talked about is Bitcoin is the system is decentralized, so there's no central controller of it. The protocol implements the rules. So for example, you've probably heard there's only ever going to be 21 million Bitcoin. And Bitcoins are divisible into, very tiny fractions. So that just implies that the value of a whole Bitcoin is likely, the buying power of a whole Bitcoin is likely to go up. It's literally the opposite of our current US dollar inflationary model. So let's go back to the mining exercise. If you guys want to just take your envelopes there, dump them out in front of you, separate the full-size sheets from the little strips. First, I wanted to point to this website, which is not rendering 100% the way it should, but this website is kind of cool because it's a view of the Bitcoin blockchain in real time, and you can see that you can literally see the blocks happening. So to point some things out, you can see that this orange rectangle represents a block from 27 minutes ago, And it's the 528,223rd block that's been mined in Bitcoin's history. And we can see that it has 1,663 transactions in it. The block value, it transferred 6,340 Bitcoins, and the fees paid were 0.38 of a Bitcoin. And then you can see these rectangles next to it are actually bigger, so the top is cut off, but they've essentially transferred more Bitcoin and had more transactions in them as we've gone forward. Or I should say, their size of the block, each transaction has a certain file size essentially. So when you're storing the blockchain on your computer, it's getting larger and larger. It's using more and more disk space, and so that's what the size of these orange squares is representing, is the size of the blocks. Because this particular block I'm moused over now only has 99 transactions in it. So based on a queue called the mempool, the queue of global transactions waiting to be processed, the miners are finding blocks, and then they're taking the opportunity to grab transactions out of the mempool. If this is the mempool, it doesn't look like there's a heck of a lot of transactions waiting right now to be processed, and that happens. Sometimes there's bursts of transactions, sometimes there's hardly any available. Okay, so for the mining exercise, I want to explain a couple things, so I'm going to write. I'm going to grab one of these just to, thanks. So I don't know if you've ever heard the term hashing, and I'm not talking about weed. Hashing turns out to be a computer science term, and it refers to the cryptographic algorithm that encrypts values. And I don't want to get super into what that entails, but suffice to say is you feed a value into a hashing function in computer code, and you get this encrypted value out that's you can decode, but for all intents and purposes, it's meaningless to anybody reading it, to the naked eye. So if you pick up any of your slips here, that's an actual hash. It's a hashed value. It's a cryptographically processed input value that put out this code, this nonsense code. But the key to hashing is that the production of this value is measurably difficult. So this is kind of a weird concept, and I hope you'll understand why it sort of feels arbitrary. But the production of a hash, so the encrypting of a value, is measurably difficult computationally, and that key point is that we can determine, no matter who the participants in the system are, where they are around the world, contributing to this system, we can by virtue of the difficulty of creating this hash value, we can determine how much compute power they must have used, and because of that, we can fairly reward them equally without knowing who they are, or having to trust them, or having to make them sign up and put their name and information into a database or something like that. So if you look at either your slip of paper or one of these pages that's representing a block, you can see the hash that won the block. Okay, so you've probably heard in Bitcoin there's this competition or lottery system where the machines are producing hashes rapidly to try to meet what's called a difficulty target. So you'll see that your printed out hashes start with a set of zeros, and then they just have a set of letters and numbers after that. So the key thing here, and this is where hashing becomes really arbitrary, is the leading zeros. They're absolutely a legitimate hash can start with just numbers and letters. It doesn't have to start with zeros. But in Bitcoin's system, what they've done is they've said, well, let's set a target of a number of leading zeros that we know is difficult to produce. So one leading zero, not so hard to find. A hash with two leading zeros, harder to find. A hash with, 5 leading zeros starts getting more and more difficult to find. So in other words, you're producing billions of hashes per second, trying to find one that has a certain number of leading zeros. Again, this is totally arbitrary patterns, but because it's measurably difficult, this is what's meaningful. We can now set a difficulty target or a statistically known difficulty of which we're going to find a winning hash roughly once every 10 minutes. And whichever miner in the world found that hash and submitted it to the network is going to win the block. They're going to win the opportunity to write transactions into the block and earn a Bitcoin reward. So it's a totally arbitrary system, but the key is that it's just designed to be fair for anyone that participates in the world, and it produces a controllable rate of new money supply. Because if somebody could cheat the system and produce half the Bitcoin today, it would create kind of like an inflationary shock, because they're just like with the US dollar. I mean, there's too much printing too fast, and it creates these price shocks that are problematic. Too much supply, not enough demand, that kind of thing. So what we're going to do is I'm going to set a difficulty target, and you guys are going to pick through your hashes, your pile of hashes, and you're going to find a winner. And we're going to basically wait for at least 2 or 3 people to say, okay, I got one, right? It's kind of like bingo for nerds. And then we'll award the winning block, and then we'll sort of talk about that a little bit. So I'm going to take some liberties. I already have taken some liberties with the discussion here, just to try to simplify it. What we're going to do is we're going to set a difficulty target of, and I want the exact number of zeros. So this is where it's a little bit different than reality, but because of the way this works, I think it's just going to be easier if we all have to count the zeros, right? And I'm going to choose more than something like 2 zeros. So let's do 7 zeros. All right, everybody go. Start picking through your hashes. Find 7 zeros and just call out that you've got it. Wow, Sherry nails it. Okay, so this is good. We have Sherry, and then some folks in the middle of the room and some folks in the back of the room. Okay, that's good. Thank you. You can stop hashing now. So Sherry, I want you to write your name on, or if you don't have it, I'm gonna write your name on my version. So okay, so Sherry won the block. Let's go all the way with it. We're gonna award you some Bitcoins. Now these are cool. Check these things out. You see that? You got the Giga Watt logo on one side, and the Bitcoin logo on there. Yeah, they're accepted. So let's look at the block sheet here. So Sherry won this block and some cheap chocolate. And you can, so if you look down under the monetary section of the block, and we've left the transaction list off because it's just this long list of little bits of Bitcoin going back and forth between addresses. But fundamentally, I guess one thing to understand is that the blockchain and this list of transactions is where your Bitcoin lives. If you think you have Bitcoin on a wallet, you don't. You have a device or a piece of software that is a window into the blockchain, and you can see the values that are stored there. But if you send Bitcoin, if I send Sherry Bitcoin, it is just transferring within the blockchain and that ledger. It's not actually moving from me to her. So anyway, the monetary section of the blockchain, of this block printout, let's just go through it a little bit. It had 1,348 transactions. It transferred 2,755 Bitcoin for 0.12 Bitcoin in total fees. So if anybody has a calculator, let's run the math. Somebody do 2,755 times today's Bitcoin price, which I think is about 6,700. Anyone? I didn't bring my phone up here. Well, anybody doing it? crowd mentality. Somebody's doing it here. I'll give you a chocolate. 18 million.
18 million, sorry. No, it's not decimals. 18,458,500.
Okay, great. So that block, and this was done a couple days ago, that block transferred almost $18,500,000 worth of value. And I can tell you, I'm pretty sure I remember that 0.12 Bitcoin is about $800. So a couple things there. Number one, that's super cheap. I think we calculated that if that were Visa's network that charges about 3% or so, it probably would have cost about $150,000 to transfer that value. So in terms of value creation or preservation or efficiency of transfer, $800 is way cheap. So one of the applications of Bitcoin and its blockchain is at the banking level, where the money transfer that goes between banks and between banks their own bank, like in different countries and things, the treasury transfers and stuff, banks are looking at this pretty heavily because it's secure and it's so much less expensive than the process of moving money through their current channels. So tremendously different in terms of value. This right here, this 12.5, this block reward, that is the new money creation or the new blockchain creation, new Bitcoin creation that took place there when that block was created. And that was the reward plus the fee. So you get the reward plus the fees on the block as a miner. That's what you get compensated for. And so you can obviously see the $800 is pretty meaningless when your power bill is, whatever. Mine's like $250,000 a month. The reward is what ends up being the most valuable, that 12.5 Bitcoin times the value of the Bitcoin itself. Eventually, though, we'll see this sort of switch where, to illustrate it, when I first started working with Bitcoin, the reward was 50 Bitcoins. Every block that you could win, you won 50 Bitcoin. Then 4 years later, it went to 25 Bitcoin. And now it's 12.5, and in a couple of years, it'll go to 6.25, and so on. This is what I mean by the production rate of new Bitcoins it is literally geometrically reduced over time. And each one of these events is called the halving. The more internet meme-y way to say it is the halvening. Halvening, which is sort of globally feared by miners, because if you can imagine, you're cranking along and you're making a certain amount of revenue, and tomorrow it's going to get cut in half. And then what we've seen so far is that the price of Bitcoin usually reacts, but not before the halving. So typically there's a few months of reaction time where the miners are pulling their hair out, and it takes a little while for the system to rebalance itself. But typically it goes back to some kind of equilibrium where the amount of mining is reflective of the amount of value getting out of the system. And if there's not enough value, a bunch of miners with bad business models quit. And that causes more of the Bitcoin to be available to those who are still participating in the system. So it's a little bit self-hedged, which is pretty elegant. Another elegant thing I think about the Bitcoin's mining system is that because there's a fixed power cost associated with producing all of this, miners cannot hoard the coins. It's really not common to find a miner who is able to hold on to all the coins they're mining. And that's really important, because if the system allowed us to just hoard the coins, then there wouldn't be any trading, and none of it would make it out into the system to be spread around. And then that would not create as valuable of a network. So Bitcoin miners are the most heartbroken because they've watched so much Bitcoin go through their hands. But I believe, and we believe, I think in general, that's good for the system. The system wouldn't have the value it has today if we weren't doing that, if we weren't forced to sort of push it out there. So now let's do one more block just for fun, and we'll do a difficulty target of 9 zeros. Go. Wow.
I cheated because I
Okay, we got Randy, and then we got, what's your name? Reva's got, okay, so Randy and Reva. So one thing I wanted to point out that I think is interesting is if this is the room, say, and I'm here, and Sherry was here, and I didn't catch the next person's name that was sort of mid-room here, but that person was here, say, and they're, for the sake of illustration, I'm the primary peer that they're reporting to. So Sherry's this far from me, and this other person is that far from me. If it's possible that if this person here was on PUD fiber, and this person, Sherry, I know you're on like dial-up, like 56K though. So if you're a nerd, you know what that is. My first modem was this, guys, to age myself. 300 baud. Okay, anyway, I digress. So what could have happened was that the message of this block announce could have reached me faster through the PUD fiber system than the dial-up, and so then this person could have won the block because they could have beat the message. And that system, that scenario is called latency. When you have a message that takes a certain time to reach the other peers and propagate. We saw this actually in the early days when we were first doing our chip. We had this competitive advantage. We could really mine a lot of Bitcoins. We were finding a lot of blocks, and we were beating out like a lot of like Europe, Eastern Europe with slower internet connections. We're just getting orphaned blocks like crazy. They're called orphans when they get ignored. So when they get, nobody wants them, I guess. I'm sorry if you're an orphan. That's maybe off color. So now we've gotten this event where we've gotten two people relatively close together announcing, and what will happen is the system has to decide which one got the message first and has a valid block that validates and is not like a fake hash, and then it rewards that miner with the new Bitcoin, and the other person gets orphaned. Sad. So in the first couple years of mining, in 2013, we launched about 1/4 of a megawatt. By the end of 2013 into 2014, we had grown that to about 1.5 megawatts. And then within the next 2 years or so, we grew to about 5 megawatts. And that was probably about 2015. We had about 5, I guess, something like that. And then in 2017, we started building really big. And we now have, I don't know, in 2017, we were at like 25. And then now in 2018, we're finishing up 55 to 60 megawatts. So 1 megawatt is about 400 homes worth of sort of average daily power use. So I'm not going to lie, we use a lot of power doing all of this compute. But I hope to show you a little bit of why it's okay that we're doing that the compute is more efficient, and fundamentally in terms of value transfer, it's a net positive. It's net more efficient. Because I brought all these, I'm going to give you your Bitcoin reward. I'm not giving 12.5 of these chocolates. Well, I'm not, because I'm sure you don't want them.
Sherry and I are selling Bitcoin.
I'm going to try to burn through the rest of this really quick so that we have time for questions. What was the time check? Okay.
Great. We still have half an hour.
We got a half hour. Okay. Great.
20 minutes.
Okay. Which one of these is it? Lectern PC that I should be on? Yeah. Got it. Any blocks come through since this one came through 2 minutes and 56 seconds ago, so that's kind of interesting. I need to refresh. Let's just have a look at how many transactions are in the most recent block, or not. So 3 minutes ago, this block was created with 1,300 transactions, 9,500 Bitcoin, so it's significantly more value. And you can see the fees, 0.84 Bitcoin, the fees were sort of relevantly more higher, I guess you could say. And you can see in this stack of transactions here, this is sort of the transactions that are waiting to be processed. This, I think the easiest way to look at this is this fee size column where you're getting bids of different fee sizes. So it's somebody, this person here bid much higher transaction fee, and so the higher the transaction fee that you bid, the more likely your transaction is going to be included in the next block. So more critical transactions, say you're an exchange or you're a financial institution or something, you really need to get those transactions in, they will bid higher. And when, back in December when price was really heading up significantly high, there were so many people trying to buy Bitcoin, and every time you buy some Bitcoin, that's a transaction. So there were so many people trying to push money into the system that there was huge competition for transactions, and so the fees went quite high. And I think that's just a sort of representative of bursts of sort of popularity and growth, but in the normal state of processing, you're not paying $20 to send value. All right, so I hope that illustrates a little bit of how the mining process works. Computers are doing that, by the way, much faster than you guys. This is an old mining rig, actually, that I was playing with in 2012, and it produces 1 billion hashes per second, a billion of these values per second, while looking for the target difficulty hash. It sounds like a lot, but the modern, standard modern device that people are getting these days, this sort of shoebox size thing with a fan on each end, does 13,000 times more than this device. So the efficiency and compute capability of these devices is rapidly moved forward. All right, so let's kind of move away from Bitcoin, I think. The tokenization of everything. We talked about how Bitcoin is a tokenization of monetary value, and we talked a little bit about how you can tokenize other things. There are teams working on tokenizing so many different things right now that they're essentially working to tokenize things like assets. So imagine like a share of a company. You can create a token of a share of Apple, and instead of having to go to your brokerage account to trade it and sell it to me, we can just exchange it directly for cryptocurrency. People are tokenizing stores of assets that hold value, like gold. If you had a big stack of gold and you wanted to allow people to trade on that value, you could say, okay, this gold is certified, it's stored over here, we're going to generate tokens that represent that gold, and then now you can trade them around between you, basically. So it's sort of unlocking value to make it more tradable. There's a project that is talking about taking oil reserve that's still in the ground, but has a scientifically provable amount of oil in the ground. And instead of actually ever bringing it up, let's just issue a token that represents the value of that. Same thing with gold in the ground. People are talking about taking core samples in a gold field and saying, okay, science says, mathematics say that there's this much gold in that gold field, but rather than bringing it up and just taking all that time and effort, let's just create tokens that represent it, and we'll never touch it. It's like a reserve, and then we'll trade on the value. So there's some crazy stuff, and then there's some really cool stuff. A lot of tokens take the form of say, like membership in a club or membership to a set of valuable resources. A coupon discount is an easy one. You'll see a lot of branded tokens in the next few years. Coca-Cola coins or something will come out, and you'll be able to redeem them at a store for discounts and things like that. So why is blockchain, from a compute perspective, becoming such a thing, right? We believe that the needs of blockchain are so different from the needs of 1990s internet that the data centers that were built that express the needs of those data centers are they're substantially different. So what we're building to host blockchain is very different from internet data center type things. But I hope you can see how blockchains can bring new apps and services that can replicate the internet functions we have. I mean, there are browsers being created that are blockchain-driven browsers that have built-in money systems in them. So when you're shopping, you're never putting in a credit card. If you don't want to see the ads, you can literally spend a little cryptocurrency each time to block the ads. There are systems where cars driving down the freeway are using blockchain to communicate to each other. Toyota did a pilot project where, I think this is a crack up, but a car is able to request that a car in front of it move out of the way. And I wish we had that here in Wenatchee, no offense, but it's like, I'll pay you a little bit of money to, you know, but realistically, if you think about what that would bring about, I mean, wouldn't you go out on the freeways and just drive real slow and just collect all the Bitcoin by getting out of the way? I mean, it's like a race to go the slowest, right? So there's some side effects to some of these ideas that I think might cause problems, but fundamentally, we're hosting blockchains more efficiently and much cheaper. And by efficiently, I mean that if I deliver a megawatt to one of my facilities, 95% of that energy goes right to compute. 5% is used for lights and some basic things. The difference, and I got a picture that kind of illustrates that, the difference in a traditional data center is that about somewhere between 50 and 60% of the power delivered to a data center goes to actual IT load or compute. The rest goes to power this stuff. So what we're looking at here is, this actually happens to be the NSA data center in Utah. So because they're listening right now, I thought, you know, we might as well give them some credit. It took them years to build this, and I think something like $60 to $70 million for the amount of power that's here. I think we've built either equivalent amount of power or very near to this amount of power in less than a year and far less than $60 million. Across the top here, these are fuel tanks for the diesel backup power generators. So in case this center goes down, they can fire it up. Yes, it's true that if I don't have this kind of backup stuff, and my node goes down, I stop processing for the network until I can get back up and running again. But there's no customer data loss. There's no services that disappear off the internet. There's no websites that go down. It just doesn't work that way. In fact, the computing devices in my facilities are not holding any kind of data that you could use. No customer data, no credit card data. In fact, they don't have any Bitcoin on them, and they never have. The values that they produce, these hashes, are sent to a centralized server to be processed and aggregated, and eventually the winning block is found, and that's where the Bitcoin is actually created. So you can't even back a truck up into one of these facilities and grab everything and get anything very meaningful out of it. So you have on the rooftops, you have the fuel, you have the chiller systems and the heat exchangers, and all this infrastructure that is built for redundancy and environmental control, right? So a data center, they have these tiers that define their functionality. They have their uptime, availability. We talked about Bitcoin's network is 100% available, has never gone down. Not saying I haven't gone down, but Bitcoin's network hasn't gone down. The big redundant power components everywhere, active cooling with redundant cooling systems, and a lot of those use liquid like water, which brings about water treatment requirements. Super high security, even security within the security. You go into a data center that's, once you get through the man traps and all the stuff to get inside, there are actually secure cages within a data center. They use massive bandwidth, which we may end up going in that direction because the transition from cryptocurrency mining only to artificial intelligence and other sort of compute as a service does use a lot of bandwidth. Typically, data centers are big boxes, right? Big, large, single-site facilities that take years to build and a tremendous amount of dollars. What we do is, the only redundancy we do is for the internet connection, because without that, that's pretty key. We don't have backup power generation. We don't use active cooling. We use air cooling. We use fans. We don't use UPS systems. We don't need water treatment. We build, at least I build these small units. I'll show you a picture in a second here, that they're like a kit and they're a small form factor and they can fit on any kind of sort of geography. So you don't have to flatten this big area of land. And we also were able to turn them up progressively so that we can get revenues generating from the first pod. So this is a picture of our 30 megawatt site up by the airport. You ought to drive up there and have a look if you get a chance. It's at the Port of Douglas Business Park. And it's just these, chicken coops with really expensive chickens inside laying golden eggs. But they're these little shed structures with all these fans in the face of them, and they just pull the air from the back through the front, and then inside is just this wall of compute, so that the computers inside only see the fresh air one time, and then it goes out the fan side. And that way, we just run with whatever the air temperatures are in the area, and the computers that run in there are okay with that. So you can see this is kind of under the roof on the back side with the fans looking sort of into the exhaust fans. So there's not much room in there. We build about 1% of the square footage floor space that a data center does. The power factor, and I won't get into how that's calculated, but it's pretty ridiculous. We're extremely efficient with the energy use. So we've talked about a little bit about how the efficiency and the sort of fast to build and cheap to build the infrastructure around blockchain can be. What that translates to is the hosting of a blockchain service can then be done for significantly less. So where a data center needs to charge $150 per hour per 1,000 watts per month, we can do it for something like a third of that. And so it's creating this sort of profit bottom line based pressure to move apps and services towards blockchain as the delivery mechanism. The participants get rewarded for their investment and participation. They get rewarded as cryptocurrency as their revenue, and the activity looks like mining. So this kind of relationship, I think, is now moving towards using the very same paradigm to do processing for artificial intelligence, machine learning, financial modeling, weather modeling. There's some work we're doing in the health space for genome sequencing and things like that. On the entertainment side, the more and more of movies and things that are being put out are CGI rendered. They're made from computers, producing this artificial virtual reality, essentially. And to give a sense, the movie Avatar was rendered over a period of 2 years with about 2,000 processors. Those happen to be the same kinds of processors we use for one of the big blockchains we process for. And because of the emergence of blockchain and the sort of revenue generating model and the growth orientation of it all, we've deployed 23,000 of those kinds of processors, and we haven't filled that site that I showed you a picture of yet. So the amount of processing being placed in one place and then networked together around the world is astounding. It's something we've never seen before, and so there's this work to leverage all of that computing power to do other great things in addition to processing cryptocurrency applications or blockchain applications. Of course, the infrastructure appeals to investors, so I think institutional investors are finally waking up to the fact that blockchain processing and mining is actually a place where they can make a safe investment in the power infrastructure, in the site with the distribution of power and the little facilities and the pods that go on that to do whatever kind of compute we're headed for in the future with respect to blockchain. So now that the institutional investors are starting to make big placements in the power infrastructure, you can bet that the system's here to stay. So there's this concern that cryptocurrency is this flash in the pan thing, and it's going to kind of wash through the area and leave a bunch of like empty buildings with a bunch of fans and stuff. There will be technology that kind of comes and goes, but this blockchain technology and apps that ride on that is here to stay, and you know it when the big money is making their investments, because they have armies of analysts putting their brains behind this. They don't make dumb or impulsive decisions.